Hey, Algebra 2. All right, we've spent quite a few lessons talking about rational equations and how to multiply, divide them, and how to add and subtract them. And today we're going to solve them. Very exciting. Let's try with something very, very simple. Solve the following equations for x and give evidence that your solutions are correct. So I'm going to try this one two different ways. So what I've done in the past when solving these, when adding and subtracting these, is I look for my common denominator. My common denominator here is going to be 2 and 3. So I'm really going to be multiplying this by either 2 or 3, which is 6. So this first expression, this first term, already has the 2, so I've got 3x over 6. Okay, the second term already has the 3, so I need a 2. So 2 over 6 equals, this last term already has the 6, so that equals 5, right? Okay, since I have a common denominator, I can actually multiply that whole expression by 6 and get rid of that denominator. And then solve for x. 3x equals 3, x equals 1. And we're done. Okay, I have x equals 1. I can plug 1 back in and double check that it works. So if I plug 1 into here for x, I get 3 plus 2 equals 5. And we're good to go. Okay, let's try one more way. If I take this whole expression and I just multiply it by 6, just plain old 6, I'm multiplying everything by 6, that would give me 6x over 2, which is 3x, 6 over 3, which is 2, and 5. And then I can solve it the same way. Okay, for me, since this is what I did when I add and subtract rational expressions, and this is what I'm going to do, and generally you'll see me go times 6 over 6 instead of 2 times 3 in the denominator. But let's try another one. Okay, slightly different problem here, actually much more simple. I have a common denominator, so I'm going to go ahead and multiply everything by 9, and that just divides everything out. So I'm left with 2x plus 5 equals 8. Subtract 5 from both sides. X equals 2/3. Cool. 3/2. You guys thought you caught me, didn't you? Sorry, x equals 3/2. Something didn't look quite right there, right? Alrighty. Okay, so let's solve the following equation. What is our common denominator? I would say I'm going to multiply everything by 12 over 12. 12 would be my common denominator. So in this first term, I don't need any changes. I already have 12 as my denominator. And here, to get the denominator to be a 12, I multiply the top and the bottom by 2. Now I can divide out the denominators, and I have x plus 3 equals 10, x equals 7. All right, so we use two methods. Actually, I used two methods for the first problem, and then I've used the same method for the second one. It doesn't matter to me which one you do. If I look at this problem, x plus 3 over 12 equals 5 over 6. Oh gosh, I said 6 and wrote 12. Let's erase. If I just multiply everything by 12, that works perfectly great too. 12 times 5 over 6 gives me 60 over 6. So I have x plus 3 equals 10. Exactly the same problem. So x still equals 7. So again, use what method makes best sense to how you do math, and we will get the same answers in the end. All right. solve the following equation. Okay, what would our common denominator be? My common denominator here is x times x minus 2. So I'm going to convert my two expressions into terms with a common denominator. So x over 3 is missing the x minus 2. So I would need 3 times x minus 2 over x minus 2. The second term is 8 over x minus 2. I'm missing the x, so I need to multiply the top and the bottom by x. Now that I have a common denominator, I can multiply through by that common denominator, which would divide them out. And I'm left with 3x minus 2 equals 8x. I forgot my parentheses. Let's solve now. So distribute. Subtract 3x from both sides. My pen stopped working. I have negative 6 equals 5x, so x equals negative 6 over 5. Cool. Let's try another one. If we look back to number 3, and we look at our denominator, what solutions are we not allowed to have? X cannot equal 0, and x cannot equal 2. Luckily, we did not get 0 or 2. Okay. I'm having pen issues today, so let's try this one. See if it works any better. Oh, to find our common denominator, we need to factor everything so we know what our denominators look like. So let's try that. A plus 2 is good, a minus 2 is good. This last one needs a plus 2, oops, a minus 2. So I need everything to be over an a plus 2 and an a minus 2. So let's rewrite everything again because I'm already out of space. Goodness. I really want to write an x, don't I? So everything over a plus 2, a minus 2. So the first expression, I'm missing the a minus 2. The second expression, I'm missing the a plus 2. I made too long of a line. I did skip a step here. I hope you see that. And that's going to be equal to 4. I can divide out the denominator from everything since they're equal, and I'm left with a minus 2 plus a plus 2 equals 4. Let's simplify. 2a equals 4, so a equals 2. Awesome. I'm going to point out here that this is the first problem. Actually, it's the second problem. We should go back to number 3 and talk about it in a second. We need to talk about extraneous solutions. That means solutions that you get that really don't work. It would be an irrelevant. And for rational expressions, it's really important that we never, ever, ever divide by 0. So for this example, I've got a plus 2 can't equal 0, so a can't equal negative 2. I have a minus 2 can't equal 0, so a cannot equal 2. But look here, we got a equals 2. That means that this problem actually has no solution. No solution because the solution we got is irrelevant. It cannot happen. We're not allowed to divide by 0 because it makes the world implode. Or if we ask Siri, Cookie Monster doesn't have any friends and we don't have any cookies. I can't remember how she says it, but it's pretty funny. So we have to check for extraneous solutions. So that's irrelevant or unrelated solutions. Okay, let's try number 5. First of all, if we look at the denominator, we can say that x cannot equal 0. And that's pretty simple to check. Those are the good ones. Okay, what is our common denominator? It looks like I need a 3, a 4, and an x. So you can either write 3, 4, and x, or you can write 12x. Doesn't matter to me, whatever works best for you. If we look at the first expression, I already have a 3x, so I need a 4. 4 times 4 is 16. The second term, oops, I already have a 4. I need a 3 and an x, so 15x. And the last one, the last expression, I need a 4 and a 3. So 12 times 3 is 36. I can now divide out my denominators. I have 16 plus 15x equals 36. Subtract 16 from both sides. X equals 20 over 15, which equals 4/3. All done. Okay, I'm going to push pause on this one and see if you can try it on your own. Remember to check for extraneous solutions. Cool. I got b equals 2. Notice between this step and this step, I skipped where I had a common denominator and I divided them all out. I hope you can see that and save a step if you feel comfortable. Let's try another one. Okay, I'm going to push pause. Find your common denominator first. Okay, let's look at this one. First, I factored out this denominator into x minus 6, x minus 2, and got what my common denominator is going to be. I then multiplied through, got x minus 2 for the first rational expression, x times x minus 6 for the second one, and 4 stayed the same. Notice I did not write the denominator. I skipped that step. And then I tried to collect like terms. So x minus 2, x squared minus 6x, 4. Rearrange a little bit and collect. Subtract 4 from both sides. Factor it and solve. X equals 1, x equals 6. Check your extraneous solutions. X cannot equal 6 and x cannot equal 2 because then I would be dividing by 0. So this answer is irrelevant and I get an answer. Okay, lesson summary. In this lesson, we applied what we have learned in the past 2 lessons about addition, subtraction, multiplication, and division of rational expressions to solve rational expressions. An extraneous solution is a solution to a transformed equation that is not a solution to the original equation. For rational functions, extraneous solutions come from the excluded values of the variable. Okay? Rational expressions can be solved one of two ways. Write each side of the equation as an equivalent rational expression with the same denominator, or multiply both sides of the equation by an expression that is the common denominator of all the terms. Okay? Pick one and run with it. I think I'm sort of using a mix of both, but if you have any questions, please star it in your classwork, and we can talk tomorrow. Excellent work today.